Now we're moving into the concept of the fundamental theorem of calculus, which has two parts. We're actually going to start with part two, which deals with accumulation functions. So here is an example of an accumulation function here. And it's called an accumulation function because the area is being accumulated under the curve from 0 to any x value. So the fundamental theorem of calculus part two basically connects differentiation and integration as inverse processes. So if you take the derivative of an accumulation function, then it will cancel out. These two concepts cancel each other out, and you're left with the original function. Now, what's most important is that it's an accumulation function where your lower limit is a constant and your upper function is a variable. We will get into a more elaborate proof later on, but right now let's do some demonstrations. So here we see our lower limit is a constant. It's an accumulation function. So that means I'm going to take this variable and plug it in. It's going to become x to the third. And once again, we'll do a more in-depth proof later on. Now here we have a constant at the bottom for our accumulation function. So if we're taking the derivative of this accumulation function, I plug in x. It's sine of x squared. And last but not least here, we have an accumulation function starting at 0. We're taking the derivative, so I'll take that variable and plug it in, e to the square root of x. So once again, we will prove this in much more detail later. Let's just get into the practice of applying it.